Did you enjoy the happy hour we just had? Excellent, excellent, excellent. We're going to talk now about a little more technical topic. We're going to talk about agentic AI workflows with ControlFlow. And before we do that, just give you a couple of little announcements. Number one, you're at a Data Community DC event. In particular, this is the Data Science DC Meetup. And we have a number of other meetups that fall under the Data Community DC umbrella. And I got really excited about QR codes recently. So you're going to see a lot of QR codes in these slides here. So if you want to check out more about dc2.org, subscribe to our mailing list, just learn about other things that are happening, check out that QR code there. We do have a number of meetups. These are some meetups that have other events happening. DataViz DC, you'll see they have an event coming up soon. Generative AI DC, the newly rebranded Data Engineers DC, it was Data Wranglers DC, Deep Learning Adventures, Statistical Seminars, Power BI Users Group, and the R-Govies here. So check out our other meetups that we have in the community. Also, if you are looking for people here to get in touch with, we do have a number of the Data Community DC board members in the room. If you're one of the people on this list, you want to put your hand up. Got a couple of hands right there. Yeah, cool. Thank you. Thank you for your work you do. And also our advisory council members too. So for the Data Science DC organizers, we have merged forces with the Full Stack DC team. So that is our exciting news, one of our exciting pieces of news here. So Prima and Ben, welcome to the team. Thank you. Excited. We try to give you lots of events throughout the year, and I think we'll have even more going forward. So very excited about that. If you want to get in touch with us, there's some information on this slide too. Shout out here to our food and space sponsor, Prefect. Thank you for giving us the space, giving us the food, also giving me my paycheck, so it's a little bit of a thing there. So modern workflow automation for data and ML engineers. Get your workflows into production. That's what we do. If you want to learn more, check out the QR code there. We are fortunate to have Jeremiah, our CEO, here with us. So Jeremiah, do you want to say a couple words about what Prefect does?
It's right there. We take workflows and we make sure that when they go into prod, we don't pretend that they won't fail, but we make sure that when they do fail, you are ready to fix them. And I just want to say thanks to everyone. We're opening our new office here today. You are part of us opening our new office, which I'm super excited about, to actually return to having a DC presence. I'm from DC. I love being here, although our team is largely remote. And thank you all for coming out tonight in the rain.
Awesome. Thank you. We do have a diversity statement and code of conduct, so I won't read it all to you, but we do try to be a diverse and welcoming community. And if you want to check out more about our code of conduct, go to dc2.org/code. If you see anything that is not in accordance with what you would expect in people being nice to each other, please reach out to one of the Data Science DC or Data Community DC folks. We do have a Slack channel where you can continue the conversation after tonight. So come to DC2 Slack workspace and join the DSDC-members channel. QR code, check it out right there, and get involved that way. If you want to speak, we have recently gotten some ducks in a row here too. So we have a form, you can fill it out, QR code, and you can apply to present there. And then we will get back to you and try to make something happen there. So encourage folks to apply to present.
Do you have a QR code where I can find the QR code?
Meta QR code, that is a great idea. Yeah. I'll see if I can get my AI agent to make one for me. We do have a couple upcoming events. Data Art and Generative AI is a title of event happening at Excella tomorrow. So check that one out. We've got Data Dive at the World Bank next week. That looks like it'll be a big event just down the road here, just a couple blocks away. Note that date now is December 18th. I put that warning there because that has changed in case you thought it was a different day. It's the 18th.
It would have been today.
Would have been today. You missed it. But no, you haven't missed it. Now it's next week. Also, Bayesian Statistical Marketing and Analytics in Python with PyMC Marketing is happening here on January 14th, 6:30 to 8 o'clock. Another Data Science DC meetup, so hope to see you at that one. Community announcements. If you have a meetup that you are hosting, if you are looking for work, if you have some service, if you are hiring, this is the time to put your hand up. I will acknowledge you, and you will briefly have the floor to say a few words about what it is that you would like to say. I see a hand in the back. Banjo.
Hey, I'm Banjo. Next week, December 17th, I'm giving a event recap. Everything I want the meeting with feedback focus on generative AI. It's at the Skills Center. It starts at 5:30. It's at generative AI DC. So if you want to learn more about that.
Awesome. All right. Yeah. Sure.
Right before that, from the Microsoft side, Azure side, I'm doing anything with AI, Copilot, 365, you name it, literally at 4 p.m. in Microsoft Office in Roslyn. Sorry about that.
Hey, just keep
two events. Come here and then go to Banjo.
just keep it rolling. Yeah, one event to the next.
Will they have food?
Food?
I don't work for Microsoft.
Anybody else got hiring? Yep, go ahead.
Hi everyone, Women and Gender Responsive Coders is coding that they're recording a party where like Women in Agile next week on the 18th at Excella. Look forward to the meetup or if not, reach out to me afterwards and we'll get you in the slide.
Awesome. All right.
Do you need secret clearance and you want to provide functional data expertise for the Army Enterprise Business Systems? I don't know why you would.
All right. All right. All right. There you go. Anyone else? All right. Sold. All right. And thank you everyone for attending tonight and being members of our community. We really appreciate it. Without you, this would not be possible. And with that, Jeremiah, take it away with Agentic AI workflows with ControlFlow.
All right. All right. Can you all hear me okay?
Yeah.
Good. I wanted to talk about something that I think is really cool, and I hope you do too, but if you don't, I won't be here too long, and there will be pizza after. But I am so excited as a like longtime ML and like 2010, 2011 circa that version of neural nets and time series analysis ML person. I have been so excited about what is happening and what's available to consumers, let alone data professionals and folks like everyone in this room. And I get especially excited about finding ways to actually harness the technology. And a little bit, I feel like people have lost their minds when they talk about agents. And the most common thing that I see that drives me crazy is people typing things into ChatGPT where they're like, make my dinner, research my stuff, do my kids' homework, and wake me up in the morning. And it's just comically out of touch with what not only the interface can support, but what the technology can do. And then you go and you look at what's being done in the developer world through LLM frameworks, and you see almost the exact opposite, where there are these hyper-precise, almost micromanaged agentic interactions that I don't even know why we're bothering with the LLM in many of them. Normal software would do just fine. And I think part of the problem is finding the right balance where you're taking advantage of what modern generative AI is bringing to the table as a set of differentiated novel concepts, but also reusing decades of software expertise and experience to actually drive repeatable, reusable outcomes. And so I have a lot of fun just trying to push this boundary, and tonight I want to share with you some of what I've learned, some of what we've put into code in an open source package that I hope you'll try out, and I'm very excited some of you already have. But this is the core observation that I start with when we talk about agentic workflows. In fact, before we even talk about this, I should have made a slide for this, I don't have one. Let me talk about what an agentic workflow even is. I think agentic workflows are one of these things that I thought was a really great description, and then it became like a VC jargon meme, and I'm not supposed to say it anymore, but here we are. When we talk about LLMs, the classic way of working with LLMs and the way that most LLM frameworks were presented, say, over the last 24, 18 months, is through predominantly like request response. I have information, I want to send it to the LM, and I want to get back information in a new form. And my colleague Adam, who is in the back, who anything that you like what I'm about to show you tonight, I would love to talk to you about, and anything you don't like, Adam would love to. Adam would love to hear it. Adam has put forward a theory that we need to write down somewhere, that there are really 4 core LLM operations. There's summarization, there's translation, there's extraction, and of course I've just forgotten. Classification, thank you very much. There are these 4 core operations, and if we really want to go and look at like an LLM program or an LLM application, our hypothesis is that you could actually decompose it into these 4 operations being run over and over. And the key thing is that iteration. So as soon as you have these iterated calls to the LLM, we're leaving behind this sort of summarize this document, extract these keywords, and you're entering a world that is somehow different and self-referential. That's the first hallmark of an agentic interaction. And I think one of the difficulties about agentic interactions is that they became so popular through tools like ChatGPT that we almost take them for granted, because what else is ChatGPT but an agentic system that is constantly passing the history? It's actually like wildly inefficient if you think about it, constantly passing the history back for the LLM's self-reference through a series of independent and stateless calls. And so when we talk about agentic applications, we're talking about iteration, which is to say we're imbuing them with some notion of state. And the other thing that's almost always a hallmark of an agentic piece of software besides the iteration is that it takes some side effect. It interacts with the world. So it's not just the iteration. A pure chatbot can iterate. A chatbot plus tools is now, in some simple sense, agentic. It is an agent that can take action and react to that action. So is that a fair enough just grounding? I know we have a lot of different comfort and experience levels in this room. Is that sound okay to everyone? Just a few nods, just, yeah, okay, great. So how do we put agents in the world? I think there's this dream that you take your little agent and you do what I said in the beginning, like do my kids' homework and make me dinner, and it runs off and it comes back, and we all know that that's not the way it works. But I think that the most true thing that I can say about all AI at its current level in all forms is that if you ask it to do too much, it will fail, but it will claim that it did it right. That's the problem. That is the problem, actually. It's the hallucination of the correct response. And so these open-ended tasks lead to problems. That is the starting point. And so the reaction has been, rather than play and explore the nuance of how to optimize the prompt. We did that. It was called prompt engineering. Everyone got really mad about it. Instead, we've moved to this hyper-precise, almost micromanaged world of building agents. Many frameworks that I'm sure many of you have experimented with are regurgitating what I would view as methods of building automated software that we rejected 15 years ago, like state machines being built by developers and explicit transformations. These are not good ways to build software where the software is deterministic, and they're horrible ways to build software when the software is stochastic or autonomous in any way. But it's easy to say what doesn't work. I want to spend some time tonight talking about what I hypothesize does work. And the best advice I ever got when we started to dig into Gen AI is to think of the software at its current level as an incredibly, incredibly capable intern, which is to say it lacks some degree of experiential knowledge that would come if it were really imbued and stuff, but it's capable of doing anything you ask it. And so the challenge of working with an agent, therefore, is to take a large task that will almost certainly go off the rails. It will almost certainly find some loophole, go off in some direction, and ignore half the task, and break it up into a series of much more achievable tasks. And the goal is to make it come back and show its work at known control points where you can assess whether it's on track or not and provide the guidance at that moment. And I would like to argue that all agentic applications can be decomposed into a balance between autonomy. I'm asking it to go off and iterate until it comes up with a response because I have faith that it will, and control, which looks almost like traditional software where I'm making single calls to the LLM, or possibly, and this is maybe the most controversial thing you can say in a Gen AI talk, no calls to the LLM because you can do it better in software. And when you can do it better in software, you should. You should only be using the LLM for those 4 core operations that are super hard to do algorithmically. And so I really, really don't like thinking of agents as a request response, as if it's just an API. I really like thinking of it as almost a black box function where it's going to take a non-algorithmic approach to producing a result, and I just need to know when is it really hard for me to write the algorithm. Those are the moments when I want to yield control, and other than that, I want to bring it back. And the argument that I would like to try to demonstrate to you tonight is that if we view the tasks that we set to an LLM as contracts between the developer and the LLM, it gives us a way to build software where you actually have this constant take and yielding of control between the developer, who lives in a deterministic, structured, in our case, Python world, and the LLM, which lives in this crazy nonsense world of anything goes and it processes strings and turns them into strings. A task is a way for those two personas to agree in unambiguous terms on how they will work together. As a developer, I create the task, I say what I want done, and I define some way of assessing whether it's done. I now yield control to an LLM. The LLM can do one thing that looks like a request response. It can do 10,000 things. It can come back and absolutely fail. The agreement that I'm going to make with it is that I will not intercede until it returns and fulfills the contract that we have set, at which time I will take control back. I will continue executing my program until the next time we enter into a contract to exchange control. And so this is my proposal for how we can build agentic software that is neither fully autonomous, which is where it goes off the rails, nor micromanaged, but it's a very simple abstraction that lets us agree how we're going to exchange control. And so this to me is how, remember, this is iterative software. So it is a loop at the end of the day. Even if it's a loop of one, it's always a loop. And so the question of building an effective framework is, how do you expose control of a while loop to a developer who does not, it's like an inversion of control problem. We're not going to enter a while loop and then program a bunch of stuff, because the while loop takes place in the agent's mind. It takes place in the mind of the LLM. That's where the while loop, the autonomous loop, is happening. What we really need is a really sane way of invoking the autonomous loop, and more critically, ending the autonomous loop without micromanaging it. So that's my argument to all of you. That's my hypothesis on what it takes to build effective agentic software, just conceptually. We haven't talked about a single thing. What I'm going to do now is I am going to show you our attempt to implement the hypothesis that I just showed you, and hopefully this will still have a kernel running. So what I'm going to do now is we're going to walk through a notebook that I put together. I'll make sure that this is available after the talk if you'd like to run it. ControlFlow is a completely open source package.
Can you zoom in a bit?
I can. How's that?
Good.
We can go further.
More? One more? One more? One more!
How's that?
Yes! Woo!
All right. What I'm planning to do here is I've put what I think are the like 7 or so just core concepts, primitives that this library exposes, that I hope you will experiment with and repurpose into complex interactions that involve an agentic LLM. But it's code, and we're having a conversation. So if something's interesting, let's spend more time, and if something's boring, let's skip through it really quickly. The only thing that you need to know about ControlFlow, if you want to do the simplest thing, is this run command. We are going to run something. And what are we going to run? The thing we're going to give it is the objective. Now, behind the scenes, what we're going to do when we run something is we are going to create a task, which is to say we're going to create a contract. We're going to spin up an LLM agent. We are going to enter into that contract, and then we are going to send it off on its rails until it fulfills the contract. So we'll talk more about those contract elements in a moment, but if I run this and Python's still running, we get a response. Our agent, who is of course named Marvin, is reporting back to us, I completed the task, this is the result, and then we can access it and this is maybe the most important thing that we're about to spend a moment on, we can access it completely as normal Python. There's no data structure here, there's no weirdness. I made a call to a function, which is typed as returning a string. I got back a string. I can now write completely normal code and forget I ever talked to an LLM. So far, so good. But we already talked about these 4 core LLM operations, and almost all of them are about the transmutation of information into another form. And so the most basic thing that we're going to add to these contracts now is what I consider to be the most basic request you can make of an LLM. Give me information in a different form. So in this example, and my hope is that, and our strong belief at Prefect is that software should be largely self-documenting. So I hope I'm being ridiculously redundant in explaining some of the things I'm going to show you, but we are going to get into more complicated things. I'm adding a result type, which means I'm taking this away from being a string function. I'm now expecting to get an integer back. And if I run the code, where is my code?
And is this connecting to a external AI server, or is this?
Sorry, it's a great question. This is running against OpenAI. This is running a GPT-4o agent. I am concerned that I didn't get my. Let's just restart our kernel. Always do live demos, everybody. Always do live demos.
Did you properly sacrifice the demo gods?
Yeah, I have been sacrificed. All right, let's get our first output, which has the import in it.
Yeah. I can. Or hotspot.
It worked once.
It did work.
You all saw it work, right? We support any LangChain compatible model. Let's see if we can just do it manually. I'm just going to run this and just make sure.
Is the internet?
Is it internet?
OpenAI. You can also hotspot off of me.
I might have to. No, we have internet.
Oh, slow though. Slow. Oh, yeah, that's there.
Internet's working.
Is
Maybe we don't have
OpenAI down right now?
Can anyone talk to ChatGPT? You think what?
Oh no, they are down. I think.
Yeah.
Oh, you're kidding.
No, literally.
All right, we're gonna show off how we can switch models then.
Woo!
If anyone, what's the Anthropic model string? Anthropic.
Yeah.
I gotta make this bigger. All right, hang on, everybody.
This is a wild ride.
We're going on a little adventure together. I apologize.
Claude 3.5 on it.
Here.
There you go.
All right. Let's go back here. Is it cf.defaults.model?
Guess who's paying for the API?
The user is paying for it in this package. All right, let's just give this one more shot. Let's restart our server. I don't know what's going on. Was that confirmed? OpenAI is actually having a problem right now? They always do this to me.
Do you need the Claude chain?
Let's just test this out. Okay. All right, Anthropic is working.
Let's get a non-lazy agent.
All right, here we are. Anthropic talks more. This is actually like a real thing, and it can matter. Anthropic talks more. And note, we let it talk because talking is part of the chain of thought, and that can be important. All right. My heart is slowly descending back down. The demo will continue. All right, I was talking about typing things, which now seems so like cute and quaint, and I love that Anthropic gives us this like debug message. But the core, we're a little big now. But I asked for an integer, and I got back an integer. Why does that matter? Because that's the contract I entered into with the LLM. We'll do a couple more of these. Maybe this is a Pydantic model now, because integers are great, Pydantic models are better. And what a Pydantic model lets us do is not just request structured information out, but it lets us really hint at what we want. So here I'm asking for a movie review, and of course I asked it about iRobot, but you could, well, I think we're actually about to do it in the next demo, but you can put, you can use fields, you can use descriptions. We've worked to take any piece of information and metadata that you're providing to the agent to hint it at a response. We're trying to take that into account while also delivering a nice structured output. And so, all right, we get all of our information, and here's this. Would watch it again? Yes, it would, because we know why. And the last thing I want to show off is one of those core operations that Adam mentioned earlier, which is classification. And so this is one of those things where we're actually going to show off a few things now. Obviously, we're starting to like build up mini programs now that are semi-useful. So I've got a couple of headlines here. For this example, they're coming from this list that I'm generating. They could come from anywhere. They could come from a user. They could come from scraping the web, whatever it is. I've got some labels that I want to apply to them. And what I'm going to do here is I'm going to iterate over all of them, and then for each one, issue a run command with a very simple objective. Now notice there's one new thing here. The result type, you can see we're giving it this list of items, which is a little weird if you're in a typing mindset. We're going to talk about that in a second. The context one is the more interesting thing. As I'm sure many of you know, context is how we talk about the information that an LLM has at its disposal to make any decision or performance operation. And so on every task, we can add context to that task. And this is not the only way, but it's one of the sanest ways to put dynamic information into the task. Here for each task, it's the headline. And so I'm going to run this, and we should get 3. Anthropic talks a lot. But we should get 3, yeah, here we go. We should get 3 tasks, and the result of each task should be one of the things we passed in. So the important thing about that is it does say result type, and we passed in a list of options. And so this is one of those places where I think we should sacrifice purity in the name of developer experience. I think we should do that a lot, to be honest with you. We are not only telling it that it can pick one of these, but we're using a trick that Adam came up with about a year ago for one of our other LLM frameworks that's not focused on agentic stuff, which is that we are doing, we're not doing it. We're not doing it here because this is Anthropic. If we use OpenAI, OpenAI allows you to provide a really restricted vocabulary that it's allowed to respond with. And so what we do is we have this little trick where if we know that you have, 1, 2, 3, 4, 5 items, we basically tell it it's only allowed to respond with the tokens corresponding to the integers 1 through 5. And what this does is it has 2 really nice effects. Hallucination becomes impossible outside the list of 5. That's really nice. And it's a single token response, which is not just cheap, it's super fast. And so Adam, I don't remember when you came up with that, but it's been like a hallmark of every piece of software that we've had since, whenever we can get that efficiency. So it's just nice. So that's a quick way to get to label and categorize something. And I think we're just going to move on from this so we don't spend too much time on it.
So under the hood, is
yes?
it making 3 calls to Anthropic or Anthropic or 1?
Great question. In that case, it made 3 calls, and it made 3 calls because I invoked the cf.run 3 times. A different thing that we could have done is we could have made a single call. We could have passed, I'm probably going to just screw this up if I try. We could have passed all the headlines in context, all 3, and we could have asked it for list of categories, and now we're saying, give me the output. Strictly speaking, this wouldn't work. The interaction would mess up. There's a way to express this. But if we ask it for a list of categories, a list of strings, whatever it is, it will output a list, and it will be hopefully intelligent enough to understand that we gave it 3 things and we want 3 things back. It's a great question. Managing your calls is tricky in an LLM, in an agentic framework, because the whole point is the iteration. And so when you call cf.run, you are invoking at least 1. But if it wants to make more, it will make more. Remember, it's going to be on its loop until it comes back and tells us the task is finished. Moving along with just things that are, nope, there we go. What if we want to interact with it? So chatbots are chatbots. One thing that I meant to put on my slides earlier, but forgot to, so I will say it now, is that I strongly believe that chat is the wrong UX for almost everything. It's extremely useful. It's extremely useful. I love it for a lot of things. When we're talking about applications and programming, I think it's the wrong abstraction. And so ControlFlow and I think all of our LLM frameworks are emphatically code first and chat second, but that doesn't mean that we don't need to get human input in. Because a invocation of a ControlFlow agent is just a function, to be completely honest, we don't have a ton of utilities for automatically getting input. From our point of view, just go get it in your application like you normally would and then call the function with the latest input. But we do have a utility for making it simple, which is exposed by just saying interactive equals true. And so here, this agent is what? It's going to ask me about my name, my age, and my favorite color. And off we go. And it says, hi, I'm Marvin. It's nice to meet you, blah, 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 blah. My name is Jeremiah, and I'm 39, blue. Oh, hang on. It only asked me my name. So I'm just going to tell it I'm Jeremiah and I'm 39. And now it has a mission to collect 3 pieces of information. I've just volunteered it an extra piece that it didn't know. And so notice it's skipping that because it already has that information, and its only job in life is to fulfill the contract.
So it's not going to waste time. It's not like we told it, ask this, ask this, ask this. That's back in the normal software world. Here I'm leveraging its autonomy to realize I gave it the information. We're going to say blue, and off it goes. And it generates a result, which now I, in my application, can use. And Anthropic's really chatty is what I'm being reminded of here. Tools. This is the second half of being, so far everything we've done is about invoking the agent. We got to talk about tools. I think in many ways, tools have become almost the most commoditized part of working with LLMs. Our implementation will not surprise you if you've spent time in any LLM framework. If you want the agent to be able to call a function, give it the function. That's it. So here I'm going to ask it to roll a die. Oh, what did I tell you? Roll a die 3 times, and after each roll, write a poem without many lines. Okay. Let's see how it does. The reason I did this is because when I told it roll a die, it was incredibly boring. It called a function. You all know what that looks like. When I told it to roll a die 3 times, it called a function 3 times. That's incredibly boring. You know what that looks like. This, I'm trying to prove out that it is actually deciding what to do in each moment and not necessarily issuing just 3 blanket parallel calls, which it's capable of doing if that was the instruction I gave it. And so again, we're leveraging the fact that I have something I want done. I'm providing a contract to the agent, and it's going to fulfill it. And if we cared to read this, it had trouble, which is ironic because I think we're about to talk about what happens when it gets into trouble. So let's ignore the error. I'm not, given that we're already in like uncharted demo territory, I'm not going to worry too much about it.
Is that because you asked it for a list of integers?
Did I ask you for a list of integers here? No, it shouldn't have been. It should have output the values of the 3 roles at the end. So, but it's a good call, and it goes back to the question that you asked earlier. How do we balance one call versus many calls? In this case, it made 6 calls at least. 1 for the tool, and then 1 to respond to the result of the tool call, but all within one sort of contract invocation. And so this contract asks for a list of ints, which can refer to anything that happened in it. So that, I'm not, very genuinely, since I'm not sure what's going on, I'm not going to waste all your time figuring it out. It shouldn't have erred, or I didn't expect it to error. Let's just run this while we're talking. Functions can have choose to call it with a parameter. I don't think that's going to be too suspicious, but we are going to ask it to call a tool with an impossible outcome. We're asking it to calculate the age of someone who's born in 2050. And so if I scroll down here, the first thing we do is ask the age of someone born in 1990. We get 34. That's successful. And now it's doing the thing that the function is designed to make impossible. And so you can notice that here, we don't blow it up the way it did a moment ago for reasons I don't understand and won't look into. Here, it detects that the function failed. It gets the error message back, and it can make a decision about what to do next because we are allowing it to do so autonomously. In this case, it even says, as expected, we receive an agent, which I think is a little cheeky, but that's fine. And it marks the task as complete, and it says, I can't do it. And we move on, and now control has been returned to me as a user to go on, and I can make use of that. In the interest of time, and since we lost some time because of the OpenAI issue, I'm just going to skip through some of these. This will all be available. Let's talk about this for 1 second. So far, everything I've done has been this like nice little single serving invocation, cf.run. But sometimes you don't want what is fundamentally a request response, even though there's some agentic magic happening behind it. And so if you care to, we can actually create the contract, the task ourselves, and then invoke it on an agent. And I think in this demo, again, for time, I'm not going to show creating agents, but for example, passing the Anthropic model instead of the OpenAI model is a characteristic of the agent. So I'll mention that at the end. Here, let me just run this. Here we're asking it to create a recipe. This is almost identical to what we did before. I'm creating my task, and then I'm running it. If you call cf.run, this is what it's doing behind the scenes. What this affords us is the ability to go and introspect the task. Which I'm actually going to do in this example here. I'm going to create a task that asks it to use a weather tool, and I'm not going to give it any weather tools. So when I run this task, it will fail in exactly the same way it did before. Oh, wait a second. Okay, it did the right thing. It just, I'm not used to it talking so much. So the task has failed here. So we have not seen this yet today. We've only seen tasks that are successful and tools that are failed. But the task is a contract. And the fact that it's failed is really useful to us. So I can now take that task object. This is one of the reasons that you may want to use the actual contract and have it available in your application instead of just the cf.run magic, is that I can now look at this task and I can see that it failed and I can see why. And this means that I can now add ControlFlow on the Python side of my application for whether a task has failed or not. I can take some conditional action. I can even invoke an agent with different instructions. Or this is how, we're not going to talk about it in this demo, but this is how I would go and take control of the while loop, is I might say while the task is pending, which is the I haven't completed state, while the task is pending, I one at a time really control how many times I invoke it, control which agents if I want to have a situation where multiple agents collaborating. And this is the entry point to like very granular, fine control over the agentic loop. Most of the time you don't need it, but if you do, this is how you like get access to the contract. And then I think this is the last thing I want to share with you. Things. So far, every one of these cf.run calls has been fundamentally independent, which is to stay stateless. Here, we are going to, I don't know if it's going to fail or if it's going to refuse. I don't know what it's going to decide to do here, but I'm going to have it roll a die, and then I'm going to have it add 100 to the roll. And why this fails depends on how much you care to think about agents and what information they have available to them. The reason this will fail is because these two calls are independent and do not have access to each other's history. This is one invocation of an LLM with all the information contained in this contract. This is a second invocation of the LLM with all the information in that contract. And so here we go. We get the first roll. It's very excited. It rolled a 1. It marks the task as complete. And now we're going to get here. It is deeply, deeply confused. It's doing like a lot of meta stuff. It thinks the previous roll was 13, which I do not think is correct. We're in like deep hallucinations here, and it marked it as successful. So here we've just seen like the worst version of agentic behavior. So our solution to this is this block of code right here, and I'll run it while I'm talking. Is this block of code right here. From here down, it's exactly the same, except for that comment. And what I've done is I've added this context manager. And a flow is ControlFlow's vocabulary for a shared context and history. Every time you invoke an agent inside of a flow, the flow is keeping track of all activity. In fact, it's doing it in a very dynamic way because every LLM provider's API has very different requirements about how you format messages, how you share messages, how you provide context. And so what this flow context does is it tracks all of this information, stores it in a format that is sort of fungible within ControlFlow, and then on demand, when an agent is running, it puts that history into its context in the proper format so it can go ahead with it. So if this worked, rolled the die and got a 5, and now the next one is correctly seeing the previous roll of 5 because it automatically within the flow loaded and participated in the shared context. So we built up a lot of ways of telling an agent what to do. This is where we start to enter actual collaborative, iterative workflows where now behavior in any one invocation can affect any other. Oh, I did have a couple other things I wanted to share with you. I'm going to go real fast. ControlFlow has a memory system because sometimes you want to share information, but it's not part of the same conversation. So I think the example we did here is user preferences. Anyone who's used ChatGPT has this built in a really, it's a very similar implementation. Each memory module is a vector store. The agent can choose if it has memory modules available to put memory into them, to write memories into them and read memory out. And every memory module has a key. So it is up to you to decide how you want to partition all of the memories. You could have, this one is called pizza preferences, which is a really terrible thing if you have many users, but pizza preferences _ user ID lets you now store this information partitioned by user ID. Just user ID would let you put anything in there. You can attach multiple memories to an agent or to a task. You can swap them in on every call to make different context available. It's a pretty robust system. In the interest of time, we won't run the whole example. Here's a very simple set of examples that we'll run. Sometimes you want your contract to sort of be created in a in a clear way, in 2 sentences explain quantum physics. Here it is. That's very nice. Sometimes I want to modify a task, but I don't necessarily want to go and modify the task definition, or I have a task object that I inherited from somewhere else in my program, and I want to change a behavior, but again, I don't have access to the raw task. And so for this, ControlFlow offers a little context manager, which lets you just for the duration, modify the instructions. And I think I did one here, which is Eli 5. So this is just, again, we have a contract with the agent. At runtime, when we issue it, we're gonna add this instruction. And the last thing I'm going to show, okay, there's one more thing. The last thing I am going to really show you, though, is how do we put multiple agents together? So it's an agentic framework. How is it that the last thing I'm showing you is actual agents? Again, this is a hypothesis that I have, that we've got agentic workflows entirely backwards. The agent is actually the least interesting part of it. If you think it's more interesting, it's because you're sort of anthropomorphizing the agent itself. Agents are just configuration. They're portable configuration so that when they're attached to a task, which I argue is the core of any agentic workflow, we inherit their configuration. So here I've got 3 agents, configuration, one's an optimist. Why didn't I call it a pessimist? I don't remember. It was late when I was mediator. And I'm building a workflow. And because it's in a workflow, they're all going to share the same history. And I'm telling the optimist and the poorly named critic to evaluate a product idea. And I think I threw in an instruction. Oh, I didn't. I thought I threw in an instruction that they have to talk back and forth a few times. Let's just run it and see what they do. And then we're going to have the mediator decide. So the first agent's going to chat. He's coming up with all kinds of reasons for why this is a good idea. He's now using a tool that we've added automatically because the framework detected that there are multiple agents assigned to this contract. And what that means is while the agent could have marked it as successful, he could have said, I'm done, the agent also had this tool to invoke the next agent. And so he, in this case, used the tool. Now the critic was given an opportunity to speak. I don't know where that just went, sorry. I don't know, we're all zoomed in, so it's all over the place, but they're going back and forth, debating, yielding to each other until one of them marks it as successful. I don't know why it keeps jumping, I apologize. Jupiter, yeah, seriously. And now one of them marked it as successful, so that final agent is stepping in to actually make a call. And so this is how we build up not just iterative, not just contextual, but multi-agent, which is to say multi-configuration workflows. This all comes together in this silly rock, paper, scissors example, which I will leave as a reader, as an exercise for the reader. The only thing that's interesting about this, and the reason I like rock, paper, scissors as a demo of an agentic workflow is like the worst benchmark ever, is because how do you play a game involving secret knowledge with an LLM? So if you try to play rock, paper, scissors, shoot with ChatGPT, it's tricky, right? You can't input your guess, because it will see it when it generates its guess. You can't ask it for its guess because you will see it when you input yours. And so obviously we can build software that like compartmentalizes stuff, but it feels to me like this has to be table stakes for anything claiming to be an agentic framework. And so you'll take from my word that the code runs, or you'll run it yourself later to prove it. But you'll notice that here we have 2 flows. And so what we're doing is we're creating 2 different shared contexts. And when the AI makes its choice, it's doing it in a flow that is independent of the parent one, which means that it doesn't see the choice when it makes its determination. We're separating the 2 threads, and then in the last one, we're going to bring those 2 things together back in the context. And so that's how, in a uniform setting, we can actually compartmentalize knowledge and not end up with this mishmash. So sorry that took a little bit longer than I thought, and sorry for the hiccup, but that's a run through of the core primitives that ControlFlow is bringing to argue if you put these things together in any way you want, they all work together, you can build complex autonomous applications without giving up control. And that ultimately is the goal. These tasks are the control points that let you trust what these agents are doing, and I'd be remiss if I didn't say that the whole thing is being backed by Prefect, so every workflow, every interaction, every tool call, every event is showing up in a UI for full introspection. Any questions? I'm happy to take them. Yes?
Yeah, does it work with AWS Bedrock?
I hope it does.
Lane change, part of lane change?
Yeah,
The lane change does.
it should work with any lane chain model that supports chat and function calling. So Bedrock has models that do.
A follow-up, not related. So you mentioned it's supported by Prefect. What's the business model? How does it make money?
This started as something I thought was cool and then took off. So the genuine business model is that I firmly believe that there's no difference between this type of workflow and the data workflows that are our bread and butter. I believe that, if anything, when you put this in production, understanding what happened and diagnosing issues is actually more complicated and harder than with, for example, an ETL pipeline. And so Prefect is an open core business. We try to make useful tools for doing work. And then ultimately, when that work spills over some boundary, we have a commercial platform for delivering intelligence over it. But this is free. I don't know where it went. This is free. This is open source.
Thank you.
Hi, there's been a lot of talk about the impact of agentic workflows on future work and future technology. Where do you predict a year from now, like this technology will be? Do you think it will be fully autonomous? Do you think? That's a big question. Big question, but I'm just curious. I think where will be a year from now?
I'll give you an answer I guarantee is right. I think the question right now is, where is the technology accruing to? So in the last year, the technology has accrued to the underlying models. Like the difference between even, Sonnet 3.5, I think, is an extraordinary LLM, especially for prose or long answers. As it intersects with what I'm demoing today, there's a really interesting interplay between what is agentic and what is not. And so, for example, the O1 model that OpenAI released recently, and I think went GA this week maybe, does this reasoning thing where it iterates. I have an argument that that's not agentic because it can't take a side effect. It doesn't have tools. If they gave it tools, would it become agentic? I think the answer is yes. And so now the question becomes less, is mimicking agentic workflows solely the playground of a developer who has a tool like this? No, you can now do that quite easily from an off-the-shelf model, but I think it's still going to require software for actually getting outcomes that are like business impacting in a way that's replicable and understandable. So I think there's always a world for frameworks for describing behavior. The more that OpenAI or Anthropic or whomever else wants to pull some of that ability and take responsibility from it, I don't know, people like me who build frameworks, like we have a little sigh of relief over that, because when OpenAI didn't run earlier, if you all were using ControlFlow, you'd be blaming me, not OpenAI, right? And we live that every day with Prefect. If a Kubernetes pod is evicted and Prefect is the tool that tells our user about it, it's our support team that gets the call, which we live with. We understand our role as the messenger, but people who build frameworks tend to like when some of the functionality disappears, if we still have a job to do in control. That's a great question, thank you. Yes?
More down to earth and technical, if you can scroll up to the very first prompt, whatever.
The very top?
Can you elaborate a bit more how you, you have a task, say hi. How do you elaborate, how do you explain, how do you define what is the goal? How the model knows when it achieves the goal?
Okay, so I actually think we're in the process of exploring what does the next version of ControlFlow do, and I actually think that we're a little overbearing in how we do that, so it's very explicit. There's a system prompt being generated that says, hello, you have a job. It is to complete this task. Here's everything we know about the task. You will be invoked until you use either a success tool or a fail tool. And we're very explicit. I think there's even a line like, you cannot talk to the user. Do not talk to the user, which is why I'm so amused by all of this. It's like, there's no one listening. Your only job is to complete it. It's very explicit. And one of the lessons that we have, this ControlFlow has been out since June, and we've just been learning a lot. As a matter of fact, we've got folks, Cody here is one of our heaviest users, I think. We've learned a lot. We've also learned we can pare some of that back, because it sometimes has a detrimental effect, which is that the prompts that we'll use will be disproportionately biased towards efficacy in the models we use most frequently. So I know that prompt works really well for GPT-4o, which is the default model we ship, because it's the modal model people choose. It works fine with Anthropic. Does it work with, I don't know, something else? I'm not 100% sure, and I think that prompt creep is one of my current major areas of interest. Can we make sure that we have prompts that are optimized for each model?
I'll let you know about llamas.
say?
Oh, please do. We have someone kicking the tires on it now. Yes?
Follow up on that. So when you have the result type, different classes or different categories, is that information injected in the prompt, or do you use traditional software engineering to make sure that the output is in that format?
Both. It is injected into the prompt, which may be unnecessary, that may be overbearing, but it's also the reason that we do this through tool calls is that the tool arguments become typed. And so a schema is generated from whatever type you want. If it's integer, it's just integer. The default is a string. And then the model is incapable of not calling that tool with the appropriate arguments, which then the software is casting back and hydrating into the appropriate type when it returns. Yes?
Do you do any task breakdowns? So when I type something, like say hi, okay, that's pretty self-explanatory. When I type something more than that, like in that case with like roll the dice and write a sonnet, like do you do this task breakdown in your framework? Or is it like my responsibility as a user to actually put those prompts as short and as concise as possible?
It's a good question. So the basic answer is it's your responsibility as the user. And the framework is letting you create them as granular or not. You could say like, write me a 10-page paper. You could say, write me a paragraph and call that in an iterative fashion. There are utilities, which I'm not demoing here, where, for example, if you use a task, this is a run command. If you use a task as a context manager, it becomes a parent task of any tasks you create under it, and the agent will typically not complete a parent task until it completes all the subtasks. So there's all these ways that you can hint at it, that there's certain things it needs to do while still creating autonomy. There's also a plan function, which is written entirely in ControlFlow, so you could implement your own version of it, which takes a task and generates n subtasks for it that it believes, if done sequentially, will be additive to the outcome. So there are ways to do it in framework, but more the framework is about giving you the tools to decide how to carve up your tasks in a meaningful way. Yes?
That may be the last question here. It is 7 o'clock. We've had a great discussion.
Oh, sorry,
so let's take this. You want it? We have one question from Will, and then Jeremiah will be around for a few minutes.
Yeah,
okay.
I'll hang
We'll be out here. You can have a drink and chat with Jeremiah a little bit, and thank you. Yeah.
Well, I guess I should preface my question then by saying thank you for the awesome presentation.
Yeah.
And
thank you for sitting through it.
And maybe this is actually later in the notebook, but can you give us a little bit of insight or guidance or practices that you found effective around allowing agents to recursively call themselves and how to monitor that and just not have it, spin and spin and spin and go in circles and run up bills?
This is one of those things where like at 1 a.m. I Slack at him and I'm like, I figured it out how to let it call itself, and by 6 a.m. he'll get another Slack from me which is like, nope, it's infinite loop, like terrible idea. So that to me is the thing just as a matter of personal interest, I'm obsessed with how do you do these multi-agent interactions. It gets messy really fast is the honest answer. If you can create flat structures, every time we've tried to let them like go layers down, I don't even know if it's right to say you get into trouble. It's more just like it kind of loses track of what it's up to. So one of the most confounding things about building multi-agent frameworks is that every LLM provider expects one AI. And so one of the reasons that we have to do all this dynamic recompiling of the messages is that if you have that optimist agent and it's saying all these nice things, and then you swap over to the pessimist agent, but the optimist messages are still there, the pessimist will decide it's actually been optimistic the whole time because it thinks that's it. And so there's this problem in the provider APIs, which needs to be now overcome by the framework. And so it's doable. We do it in ControlFlow, but if you keep pushing that and go deeper, it can lose track of its own mind, I guess is the way to put it. So if you can do it in a flat structure, and I think most problems can be rewritten that way, I recommend it. But this is one of my personal areas of interest, but I haven't found something that I'm willing to support the GitHub issues on quite yet.
All right.
Call there. I'm happy. I'll take your question out there if you like.
Thank you.
Thanks for sitting through that, everybody. Thank you.
All right. Stop stream.
Where will this